Okay, so right now I'm going to be talking to you about metric conversions. Conversions are super important to be able to do very naturally in all science classes. I'm going to teach you two ways. I'm going to teach you how to do it by moving the decimal and by unit analysis or by the crossing out method. Both of these are useful in a variety of different circumstances. Sometimes one might be easier than the other, or you might just pick with one and stick with it all the way through. Okay? So this is the metric conversions chart. The most important ones are milli. For meters, we use centimeters quite a bit. This is the base unit. That's like where everything comes from. And this is kilo. Okay. What this conversion means, okay, is, for example, for milli. If I have a millimeter, which is mm, that's going to be 0.001 or 10 to the negative 3 of 1 meter. That's its multiplication factor. So if I ever had to convert meters to millimeters or something like that, you can use the multiplication factor. This is the base. Okay? The base units are grams for weight, which we abbreviate with a G. So say we were talking about milligrams, we would use mg. If we were talking about kilograms, we'd use kg. Another one that's important is the meters that we use for length. That's in m. So if we were talking about millimeters, we would use mm. If we were talking about kilometers, we would use km. Okay? And then there's liters. Okay? Liters is the unit for volume. We use milliliters a lot, which is ml. And every now and then we use kiloliters, but a kiloliter is typically expressed as a cubic meter. They are equivalent, so we typically use that instead. Okay, so let's go ahead and do some examples. That'll be the easiest way to learn this. Also, though, before we do that, some equivalencies that are good to remember is because a millimeter is 10 to the negative 3 meters, there are 1,000 millimeters or milligrams or milliliters in 1 meter. Okay? For centi, there are 100 centimeters in 1 meter. Okay? This is the base unit. There's 1 meter in, 1 meter. No prefix there. And for kiloliters, it's 10 to the positive 3. It's 10,000 times of a meter. So there are 1,000 meters in 1 kilometer. Okay, so that's how these work. These ones are the ones that you should pretty much have memorized. Okay, and again, remember, since there are 1,000 meters in 1 kilometer, that means there are also 1,000 grams in 1 kilogram and 1,000 liters in 1 kiloliter, etc., etc. So let's go ahead and do some examples. Okay. Let's do a basic one where we convert centimeters to meters. Sorry. Okay. Centimeters is right here. It's 10 to the negative 2. So first, let's go ahead and think about which number is going to be bigger. Which one's bigger? Meters are bigger. Okay? That means that our number must be smaller in order to maintain that equivalent. We want to convert it. We don't want to change the number. So our answer must be smaller. Okay? So I'll show you way 1, which is move the decimal. Okay? Centi is 10 to the negative 2. Okay, so if we have 256 centimeters, okay, the decimal is right here. We need to make this number smaller by 2 orders of magnitude. Okay? It's like timesing it by 10 to the negative 2 or timesing it by 0.01. When you do that, the decimal moves over 2 places. Okay? So 256 centimeters is equal to 2.56 meters. And that makes sense. There's 100 centimeters in a meter. We moved the decimal over twice. This number is smaller. We're good to go. Now let me show you the second way that you can do this. Okay? 2 is unit analysis. Okay? So we start with our known, 256 centimeters, and then we times it by the conversion factor. In this case, the one that I know is that there are 100 centimeters in 1 meter. I know this because I memorized it earlier. That's the order of magnitude that it is different. 10 to the second is 100. Okay, we're good there. Well, 10 to the negative 2 is that number, but we're going to be dividing instead of multiplying. So there are 100 centimeters in 1 meter. Okay, that's called a conversion factor. Those two are equal to each other. Okay, so that is equal to 1. That's why we can use it as a conversion factor. The centimeter units and the centimeter units cancel out. I have 256 divided by 100. Okay, so it comes out to 2.56 meters. And that would be my answer. Oops. Okay. Let's do one more example. Okay. Converting milligrams to kilograms. Okay. In this case, kilograms is still bigger. Okay, we know a kilogram is a lot bigger than a milligram. Okay, so our number must be smaller in order to maintain that equivalency. Okay, so I'll show you option 1, which is the move the decimal. Okay, for this one it's a little harder because they're on opposite sides of the base unit. Okay, so kilo is down here at 10 to the third. Milli is up here at 10 to the negative 3. So that's 1, 2, 3, 4, 5, 6 orders of magnitude different. Okay, 10 to the negative 3, 10 to the third. So I'm going to be moving the decimal 6 times. So let me write it, the number. Okay, it's a whole number, so the decimal we assume is at the end. I'm going to be moving it 6 times. 1, 2, 3, 4, 5, 6. It ends up over there, and my answer is 0.7812 kilograms. Okay? And that makes sense. That number's smaller, so these two are equal to each other. Okay? Let's go ahead and do this one the other way. Okay. So I don't, off the head, know how many milligrams are in a kilogram, but I do have memorized that there are 1,000 milligrams in 1 meter, or in 1 gram, sorry, and that there are 1,000 grams in 1 kilogram. Okay, so I'm going to be using both of those as my conversion factors. Okay, times and a line. I know that there are 1,000 milligrams in 1 gram. Milligram units and milligram units cancel out. I'm left with just grams. And then I also know that there are 1,000 grams in 1 kilogram. Okay? Gram and gram cancel out. I'm left with kilograms as my unit, which is what I wanted. So basically, I'm dividing this by 1,000 twice. Okay? And when you do that, you end up with, what do you know, 0.7812 kilograms. Because these zeros weren't significant, we don't need to keep them on the number. It's totally fine to just write it like that. Okay? You'll get the same answer no matter which method you use, so I suggest practicing both of them until you get used to it. Sorry for that. Tried to erase and I accidentally moved it. So, when doing this, you can either memorize these factors, or I would suggest memorizing this part of the table. Okay? An easy way to do that is from going to the biggest to the smallest. It is king for a kilo, Henry. Okay, those ones are there. We don't use them that often, but they're still there. Died. Drinking, or died by, for the base, by drinking chocolate milk. Okay? King Henry died by drinking chocolate milk. Kilo, hecto, deca, the base unit, deci, centi, milli. That can help you remember the order of magnitude that they're all different by. Okay? Or you can just memorize these 4. Okay? And that should be good for solving the majority of metric system basics. When you want to convert from terabytes to gigabytes, you might have to look up that order of magnitude.